Well, I'm back. I'm Tim Bondelid, part of the NHD Plus team. I'm going to talk about linking data to the NHD Plus data. Okay, the objectives I'm going to cover are, we want to learn about NHD's referencing system, especially reach codes and measures, how they work on points, lines, water bodies, coastlines, and also a little bit about COM IDs and how they relate with reach codes and measures. I'll introduce a couple of indexing techniques and tools and some of the databases that have been linked into NHD Plus and which provide a lot of the value, extra value to the whole system. And the agenda is going to follow these objectives very closely. I want to talk about reach codes and measures, how they're assigned, a little on their maintenance, on linear reaches, water body reaches, and the coastlines, some indexing tools that are available to you, and the databases that have been linked. A big part of the reason for this hopefully will get us grounded in the nomenclature of the pieces parts. It's really fundamental that we all be on the same page in terms of reach codes, measures, and COM IDs. Okay, here is what is a reach and what is a reach code. Here, this yellow line is basically, that's a reach, okay? And that has a specific reach code. Now, the thing about a reach code is it's permanent and it is stable. So that reach over here has been broken up into 4 pieces because these 3 streams have been added in, okay? But that reach code does not change. Now, reach codes can change, of course. Nothing's ever 100%. For temporal changes, times change, or to, like with a backhoe, okay, or correction of mapping errors. Those will change our reach codes. The reach codes are basically the HUC 8 code, which was covered, the whole HUC level system. This is the 8-digit code, which has about 2,100 HUC 8s in the continental United States, plus a 6-digit number added on to that. That makes the reach code unique across the country. The measures, you have a from measure at the bottom of the reach and 100 for the to measure at the top of the reach. So that defines the reach with the from measure and the to measure. The measures go upstream and are proportional to the length along the reach. Now, when a reach gets broken, they all get the same reach code. For instance, all of these pieces will have a reach code of 0604, 0001, 000185. All of them have the same reach code. Each one, though, has separate from measure to measure values that define it. For instance, this one goes from 0 up to perhaps 45, which was 45% up the original reach. So the reach code from measure and to measure still uniquely identifies that piece of river, and you still get a unique identifier for any point along this original reach. Okay, like I said, reaches are permanent and stable, and databases linked to NHD Plus should be using reach codes and measures to link to them, because COM IDs can change, and the COM IDs that we've talked about that knit everything together, those are not permanent. If we have an update to NHD Plus, those COM IDs will change. But if you have things linked to reach codes and measures, you're going to be okay, because those are permanent. Now, it is easy to move back and forth between COM IDs and reach codes, tabular information in the value-added attributes, as well as the NHD flow line tables. You can do that. Now, there is catchment-based indexing and catchment-based data building, which is a unique, which has to use the COM IDs, basically. So there's a bit of a, I wouldn't call it tension, but there is a bit of a dichotomy that we have here between reach codes and measures and COM IDs, which is a fundamental atomic unit. Now let me talk about linear referencing. This is an important concept here. The NHD flowline.shape contains a linear referencing system based on reach codes and measures, so you can use the NHD flowline for assigning reach codes and measures, or if you have the reach codes and measures, you can render and link to the NHD flowline. And the measures, again, go downstream to upstream for lines. The measures go clockwise around the country on coastlines. The coordinate ordering is the opposite of the measures. The coordinate ordering in the NHD flowline goes from upstream to downstream, and it goes counterclockwise around the country on the coastlines around the United States. Now, here's what basic NHD plus reach code and measure would look like for a point. This would be its reach code, 06040001, 0000838, measure of 62.64771. That uniquely identifies that point on that reach. And if there are changes or updates in NHD plus or in NHD, that reach code and measure will still get you to that point in the network. I've also included COM ID here, just so you see that this particular stretch of river has that particular COM ID. Okay, here now for lines, again, you have a reach code and a from measure and a to measure. Now these three particular segments down here in the southern end in this snapshot all have the same reach code ending in 3271, but they have different from measures. This one goes 0 up to about 36.5. This one goes 36.5 up to 51.8, and then this one goes up to 100. So this particular reach at some point was divided into these three pieces. Now anything that you've indexed with reach codes and measures will still work on these, even if they've been broken up and if they get broken up in the future into many more pieces. In water bodies, the water body, again, it has a unique reach code for that water body, and so this water body here will have a unique reach code. Now the artificial path going through here, or the artificial will have, these will have reach codes and they will have COM IDs, and as Cindy was talking about, there is, in the table, there is a water body area COM ID for this particular flow line that relates then to the COM ID that exists for this water body. So it gets you the crosswalks between water bodies and the artificial paths that are in there. Now, finally, along the coast, those also have reach codes and from measures and to measures defining coastline segments. Now, the neat thing about coastlines, and in California you may find this really neat, is the coastlines are part of the network and they can be routed. You can route along the coastline, or you can route up the coastline, and then the tributaries as you encounter them, they're in the flow table, and they also work in the VAA navigator. So you can navigate the coastlines. That can be very handy for discovery of data between 2 points along the coast, or upstream, if you will, upstream from a point on the coast. Now, I'll talk about some of your basic indexing techniques. Native ArcGIS has some nice tools for indexing, and there is snapping points, okay? There are many tools for doing that. You can use raindrop tools. You can use the flow direction grids, flow accumulation grids, to use raindrop tools to route down the network to get to points. And then there is catchment-based indexing. You can do point and polygon, and just for points in that polygon, and then you connect to that COM ID. Now, from that COM ID, you can get the reach codes and measures that associate with the COM ID. And then you have water body indexing. And I'll talk about the water body indexing a little bit more. I'll show you an example. It's a very neat new thing. And then we have the CA3T tool, which does allocation to catchments, and then it does accumulations along the catchments, which is really great for taking your spatial data and hooking it into the network. Now again, like native ArcGIS is very simple to do. Exercise 2, I mentioned exercise 8 in my little talk beginning. Exercise 2 is a very nice place to see the basics of doing snapping of points to NHD+. You can also do lines to NHD+. EPA, on the EPA water system, Curtis was showing that site a little bit ago. The water system includes indexing with a variety of techniques, including raindrop tools. A very common tool, which will be good for you to get familiar with, especially when we get NHD+ able to use it, is the Hydrography Event Management Tool, or the HEM tool. You can find that at the NHD website, and very soon we will have NHD+ available in a file database format compatible with the HEM tool, so you'll be able to use NHD+ with the HEM tool, and that's become a standard indexing tool, very powerful. And a new tool coming is a USGS Fisheries Web Indexing tool. That's in development, and that will be coming soon. Now, quickly, indexing with native ArcGIS. Basically, there are only two things. You go to the linear referencing geoprocessing, you locate features along the routes, and then you can make a route event layer, which lets you render and draw these points. That's all there is to it, to connect your points and get your reach codes and measures on NHD flow line. So you create a point file, you locate your features along the sites, and then you make a route event layer. And you can read exercise 2. It's very good at stepping anybody through using that to do your basic connecting of points to NHD+. And here's what happens when you use that tool. Here I have 4 points that I've indexed to NHD+, located on the routes. Now I've rendered them. You have a reach code, and then you have a measure for each of these 4 points. You can do the same sort of thing with lines. Okay, so it's a very, very straightforward way to get your points indexed onto NHD+. This is conceptually what a raindrop tool will do, is you have something that you want to index to it, and it'll take you down until you actually hit a flow line, or you can continue on down. So you can use raindrop tools. Again, in the water system, there's a web tool for doing raindrop indexing. Now, this is something new called the catchment indexing process. And what it does, it connects lines to NHD+. What it does is it links non-NHD+ linear data to NHD+. And there's a poster here that explains that really well, and Wendy Reed is here, and she can tell you all about it. and Laura also can tell you about it. It solves a really big problem because, for instance, states will provide their data for their 303D and impaired waters in a non-NHD plus format. They're using whatever their own coverage is, but those need to be connected to a standard base map data, which EPA is using NHD plus. And what catchment indexing does, it takes advantage of the catchments, but then it puts some intelligence of the network into the process. So it captures what the real intent of the indexing of that line that you want to index, what the real intent of that is. Here's how it works. Here, the blue is, this is the non-NHD plus line that we want to get connected into NHD plus in some sort of, systematic way. Now, here's one of the, if we just assigned it to the flow lines or the catchments, well, let me point out, this line clearly wants to follow this main stem, that blue line. That's the actual intent. The problem is, if we just used the catchments, it would pick up this tributary line here, which was not, if you will, the intent of what this line is. This line is supposed to be the main stem. However, the NHD plus network has a lot of intelligence and a lot of intelligence that crosses with the catchments. So when those are put together, you basically wind up with these catchments here, which are the main stem, and those catchments then reflect what that line, that non-NHD plus line is, and you notice it left out that tributary. So there's intelligence built into the catchment indexing. It's a very powerful technique for putting a lot of non-NHD plus data together, which is a real important thing needed at EPA. Now, linking spatial data NHD plus with catchments, you have stream flow, you have temperature, you have precipitation, you have land cover, you have all sorts of different spatial data. The catchment attribute allocation and accumulation tool, which is available as one of the tools on the NHD Plus website, will let you allocate your spatial grids to the catchments, and then it can accumulate that data as you go downstream. So, for instance, you can get your land cover breakouts, you can get mean annual temperature working downstream, et cetera. And the NHD Plus extensions, which we'll cover later, have a lot of data sets that have already been processed. Cindy has mentioned some of those. And there are other catchment allocation and accumulation tools that are being used by a lot of different organizations. NACWA uses several of their own, for instance. It's a sort of fundamental capability of going from the spatial landscape to the network. That's a fundamental breakthrough of NHD plus. Now, there's a wealth of data that has been linked to NHD plus. For instance, all of the flow gauges have been linked in, and that's available in the NHD plus national data. So we have the flow gauges as just part of the download of NHD plus. There is a lot of data from EPA program databases that are linked through the water system, and that's the URL for it. Again, we'll make these slides available so you don't need to type this in real fast, and you'll be able to get to it. We're working on having the watershed boundary data set pour points linked in. Dams have been linked in. And an interesting thing to do is go in the NHD Plus applications, go to the applications page, and you will see lots of different interesting data that has been linked by various people. One of my favorites is the Norwest project has linked a lot of temperature data, and there's a lot of temperature data available for California, for instance, stream temperature data, which is, I mean, really useful. Now, here basically is the, this diagram is a classic. Tommy has shown this. This is a classic diagram of the waters data architecture at EPA. This is a central starting point to get to the data and get to the data linked to NHD. Non-point source grants. We have TMDLs, water quality assessments, all our STORAT monitoring data, discharge facilities, and there are several other databases that are linked in through the waters database. So there's a lot of data, a lot of work already done for you where you can get this information when you're working with NHD+. And that's, so anyway, we're at the end. And again, you can get additional information and get to NHD+ support at epa.gov. And that's the end, and thank you very much.
Is Mike Tinker present? There he is. Mike, could you stand up? Tim talked about the HEM tool, the Hydro Event Management tool. Mike's the guy. He's the owner and the driver of that tool at USGS, and if you're interested in the HEM tool, talk to him. We will have file geodatabases of NHD+ data by BPU posted. We hope to have them posted before this workshop, but you know how those things go. So soon after the workshop, we'll have them. So if you want to use the HEM with NHD+, you'll be able to do that. It will not work against the NHD+ shape files. It requires a file geodatabase. Yeah, attributes part 1. Are there any questions for, we had a question and answer section in the agenda, which we sort of skipped right over. For anybody that's spoken, yeah.
Yeah, I have a question. The NHD reach codes, just a question about their permanence. At one time, they were based on the HUC 250K HUC8s when it has the first 8 digits of the HUC8. I was part of the watershed boundary data set, and in some parts of the country, those HUC8s got significantly altered. And I'm wondering if an exception was made during that time frame where all the reach codes now correspond to the watershed boundary data set HUC8s.
Right at the end of NHD+ version 2 processing, we synchronize the reach codes with what we call our WBD snapshot. So when you download NHD+, you get reach codes that match the WBD snapshot that is part of NHD+. Yeah.
Well, I was curious to know whether you guys developed any tools for indexing using QGIS as well.
Using what?
QGIS, the open source GIS.
Yeah, the question is, do we have any open source tools that do indexing that we support and does QGIS even do linear indexing? I don't know.
I am not aware of any open source tools that do indexing. That doesn't mean there aren't any. A lot of people have been developing NHD+ open source stuff.
And that certainly doesn't mean NHD+ is not usable outside the Esri environment. Lots of people have been taking NHD+ and doing things with map server and with QGIS and all kinds of things.
Right, which is, a lot of people say, well, why are you distributing in shape files and grids and DBFs? We did that because all of those are open standards and accessible through other GIS products. And we didn't have the resources to distribute in a lot of formats, so we've stuck with that because it does provide access to everybody.
I'll also add, and I'll talk more about this tomorrow, but Dave Blodgett in USGS has taken the whole national data set of NHD Plus and imported it into PostGIS. So there's, and he's got a nice write-up on how he did that. So I'll provide some links to that tomorrow. And then I believe we had a question here.
Okay, so you're using the NHD medium resolution reach codes. Is there an easy way to crosswalk that with high resolution reach codes?
Easy? I'm not sure I would classify it as easy, but we just did a comparison. When high resolution NHD was built, the process involved conflating the medium resolution attributes onto high-resolution geometry, and the reach code was one of the things that was conflated. So when, back in 2007-8 framework where the 1 to 24,000 scale high-resolution was finished, the reach code correspondence was very, very good. Now it is about 75%. We checked it just 2 weeks ago. So 75% of the medium resolution reach codes exist in high resolution. So it's not bad. Oh yeah, obviously on main stems you're going to do really well. The biggest change in high res is where a lot of detailed data was added. Are there other questions? Okay, so into third.